Hello everyone. Hello, welcome, lovely greetings. Navin Karke this side with another episode in physics. और आज हम किस बारे में बात करने जा रहे हैं? The topic is very clearly written. That is motion in a straight line. This is going to be the continuity of the topic that we studied last week. And last week, it was quite interesting session. आप लोगों से बहुत अच्छे responses आए थे and believe you me guys, जब आप लोग response भेजते हैं, that triggers us, that fuels us up. तो आज भी मैं आशा करता हूँ I will be expecting responses from you, but हाँ, response का मतलब ये नहीं है कि आप कुछ भी भेज दें. I'll be putting up the questions और आप इन questions के answers जरूर भेजेंगे. I'm very much optimistic about that. Okay, and we are going to continue with the idea of motion in straight line and what I have been saying. हम basics पे बात करेंगे. Basics yet misunderstood या many times less understood. पूरी तरह से core conceptual बातें करेंगे. Alright, that will be the case. They are very simple. और क्लास 11th के जो beginning में जितने भी problems आए थे, आज वक्त है चुन चुन के बदला लेंगे. We are going to talk about every detailings, every minutings, or it's really going to be fun. So let's begin. And by the way, this class is being broadcasted live through Airtel DTH. तो आपके जितने भी answers हैं, आपके जितने भी queries हैं, if you want to send it, there is only one channel of communication and that is WhatsApp. तो आप WhatsApp number कहाँ लिखूं? All right, let me write it here. 9311883484 will be my WhatsApp number. Or any given queries, any given discussion, you would be sending in this WhatsApp number. और कोई भी channel मुझे दिखाई नहीं देता. Many a times I see that students, they say hello, या उनके कुछ queries हैं, उनके कुछ doubts हैं, they find it is unanswered. That's only the reason because you're not following the right channel. Let's start, shall we? Okay. और आज, for all this broadcasting of the class, for all this technical support, राजेंद्र जी हैं जो मुझे support करेंगे in all the technical part, conduction of the class, plus जितने भी आपके messages हैं वो visible करवाने में is very much instrumental. चलिए, let's start. Motion in a straight line के beginning में, the first thing that we'll talk about is calculating displacement from velocity. Till last class, I call this as the forward gear and the backward gear. Till last class, we have talked about the forward gear. कि position की मदद से how do we calculate the velocity. And today, we're going to talk about the reverse gear. Now, the first question here is, if I say that displacement is equals to velocity multiplied by time. Now, you see many times, again, this is a very basic thing, but still, many people fail to understand it. कि अगर आपको velocity दी गई है and you got to calculate the displacement, then you write displacement equals to velocity multiplied by time. What would be your response? I would like response from you. That this is always true, yeah, this is sometimes true. What is it? Option number 1, आपके लिए आसान कर देता हूँ. This is always true. And number 2 is, this is sometimes true. What is it? I would like the answer from you people. Displacement equals to velocity into time. This is always true, yeah, sometimes true. Come on people, I need the response. Response चाहिए और उसके बाद हम आगे बात करेंगे. We're going to go with a very beautiful concept. Okay, so the first option I can see Ajay from Delhi, he has sent that not always true. Okay. Yes, Ashi, how are you doing? Last class I remember you had been there. Yes, Bhavna. Number 2, that's great. Nilesh Drishti, always true. तो मुझे कुल मिला के I could see there are mixed options. Some people are saying always true. Some people are saying sometimes true. So actually, if you were thinking that it is sometimes true, then congratulations. That is the correct answer. यानी सबसे पहली बात, हम ऐसा नहीं कह सकते that displacement is always equals to velocity into time. तो कैसे कैलकुलेट करें? Let's see. बहुत ध्यान से देखिए, we are not going to. Okay, there is Aryan Dev Sen. Okay, last time you were there as well. That's great. It's sometimes true. बिल्कुल सही, बिल्कुल सही. Now, how do we calculate? एक बार understand करते. All right, let's see. We do in this way. Velocity equals to dx by dt. That is the definition. और ये ध्यान दीजिएगा, x is not displacement. X is the position. The derivative of position with respect to time. That is what we call as velocity. तो एक काम करते हैं, इसे हम लिखेंगे dx. That is equals to v dt. और एक small pro tip. The pro tip is, जब तक आपकी जो इक्वेशन है डिफरेंशियल फॉर्मेट में है, डिफरेंशियल फॉर्मेट का मतलब ऐसे ही dx dt in that way, it is generic. Generic का मतलब it's always valid. कुछ भी चीज आपको सोचने की जरूरत नहीं है, अब तक it is a generic one. Now let me integrate. अभी भी it's generic. It's valid every time. ये लिखते समय आपको सोचने की आवश्यकता बिल्कुल भी नहीं है whether this expression is always valid, sometimes valid. All right. Now let me go further. एक बार लिमिट रखते हैं. At t equals to 0, यहाँ पर लिमिट रखेंगे t की. At t equals to 0, I would say the value of x is x1. All right. At t, अच्छा यहाँ पर भी एक गलती हो सकती है that हमारी एक टेंडेंसी रहती है that we always say okay at t equals to 0, x equals to 0. But जब तक क्वेश्चन ने ये नहीं दिया है that the particle begins from origin, we can't say this as 0. It has not said yet. तो इससे बेहतर है safe side में रहने के लिए let's put at t equals to 0, x is x1. At t equals to t, the x is x2. Now further, let's try to see. ये बन जाएगा x2 minus of x1 and that is integral v dt. अभी भी आपको कोई भी चीज सोचने की जरूरत नहीं है. It is still in the form of differential. So still it is generic. अब देखते हैं what is x? X is the position or change in position. That's the LHS. The final position minus the initial position. और change in position, इसे हम कहते हैं displacement. So this is now coming out to be displacement is equals to integral v dt. Limit will be from 0 to t. So this is the generic expression. Okay, this is the generic expression that displacement is calculated by integral velocity with respect to time. ये है generic equation. ये equation आपको कभी धोखा नहीं देगी. It's always valid. Integration of velocity with respect to time. But lot many times what happens is that we get a condition कि अगर velocity is constant, मान लेते velocity की value constant है. Now just try to see if and constant. Then we know by the idea of mathematics, if anything is constant, हम उसे integration के बाहर निकाल सकते. So in that case, I will get displacement is equals to v जैसे बाहर आ जाएगा, that's going to be velocity multiplied by time. Now यहाँ से देखिए we had started our discussion from here. तो आप सभी में जिन्होंने sometimes true लिखा है, you are perfectly right. और वो sometimes true में condition क्या है? The condition is that the velocity has to be constant. Like अगर हम example के तौर पे देखें, अगर velocity suppose 3 meter per second है, now that is a constant value. Displacement निकालने के लिए you can directly do this. वैसे आप ये भी कर सकते हैं. This is the most generic. The mathematics is automatically going to take care of that. कि अगर constant है, अपने आप बाहर आ जाएगा. बट अगर आप चाहते हैं कि मैं बार बार इंटीग्रेशन साइन ना लिखूं, आई डोंट वांट टू फॉलो अ लॉन्गर अप्रोच, फटाफट अगर वेलोसिटी कांस्टेंट है यू कैन डू दैट. बट सपोज अगर वेलोसिटी की वैल्यू 2t ऐसे दी गई है, इन दैट केस यू वुड सी दैट द वेलोसिटी इज वेरिएबल. एंड इफ द वेलोसिटी इज वेरिएबल, आपके पास एक ही ऑप्शन है, इंटीग्रल v dt. I think that truly makes sense. तो आगे से इस point पे you should promise me that you would never ever do that mistake कि simply writing displacement is velocity into time. You know, this is a kiddish job. ये high school level की preparation है. But now you have to grow up, right? So now you could see this is how we calculate it. आइए शुरू करते हैं now with a numerical. All of you are ready perhaps? Right? So here it is, the numerical. The velocity of a particle that's given as at plus bt square. साफ पता चल रहा है that the value of velocity is variable, where a and b are constant, but there is a factor of t. And we got to calculate, it's a distance. और दी गई है velocity. The distance traveled between 1 second and 2 seconds. And this had been asked once in NEET. You know, ऐसे question देने का मकसद ये है, you would get the true idea that what sort of preparation you need to do. Interestingly, आप देख सकते हैं, यहाँ पर velocity is always positive. Alright? So in that condition, distance कहना और displacement कहना, it's the same thing. तो वहाँ से तो हम बच निकल आए. Now there is no question of point of reversal and everything. So if I want the value of displacement, अब मेरे पास formula है, and that is integral v dt with the suitable limits. Let me put the value, and I would see that is at plus of bt square integral dt. Limit of time will begin from 1 to 2. So that has been done. Baki, I believe simple stuff of integration is never a problem with you. So at का जो integration है, that becomes a t square divided by 2, and this comes out to be bt cube divided by 3. Upper limit 2, lower limit 1. अब एक साथ करते हैं. T में upper limit will be 4 minus 1, that's 3. So this is going to be 3a by 2. और यहाँ देखते हैं, 2 to 4 to 8 minus 1 is 7. So 7b by 3. So that is the value of displacement. और जैसे कि हमने कहा था, in this given question, the value of distance and the value of displacement, that is same. Simple for the reason because there is no turning point. I hope that makes sense, right? All right, so we got this particular calculation. और मान लेते अगर इसी में सवाल आपसे additionally पूछता that in the same interval calculate the average velocity. तो करना क्या है? You have the total displacement, you divide by the time, and what's the time interval? 2 seconds minus 1 second. The time interval is 1 second. So displacement divided by time, that is what you call as the average velocity. Actually, kinematics, it's not difficult, right? So that goes in a very, very straightforward manner. Guys, we are talking about the reverse gear. Reverse gear में we are seeing that how can displacement be calculated with the help of velocity. और ये तो रहा numerical technique. Numerical technique में this is the given expression how you calculate displacement with the help of velocity. But we also have a graphical approach. और ग्राफ की सहायता से हम displacement निकाल सकते हैं if there is a velocity time graph. So let's see how to do that. एक चीज तो आप मान लीजिए whenever you are going through the reverse computation, reverse gear, velocity से displacement, something related to area will be there. और अगर forward computation में है something related to slope. ये एक rule of thumb आप बना सकते हैं and this is never going to betray you. जैसे कि पोजीशन की मदद से अगर आप velocity निकाल रहे हैं, so you are going in the forward gear, तो वहां पर slope will be there. Velocity की मदद से आप acceleration निकाल रहे हैं, again you are going in the forward gear, something related to slope. But अगर आप reverse आ रहे हैं, with the help of acceleration you are going for velocity, there will be area. With the help of velocity you are going to displacement, there will be area. So you know इस तरह से एक rule of thumb आप बनाएंगे, आपको approach करने में काफी ज़्यादा आसानी होगी. So let's see how can we go with that. So here's the case. We know that displacement is equals to integral v dt. That's the displacement. अब तो बड़े हक के साथ we can say we know that. क्योंकि just इससे पहले we have discussed, right? Then this is the format of area because integration is always associated with area. तो इसे हम क्या कहेंगे? This is the area under VT graph. इसे हम ये कहते हैं. This is the area under VT graph. So that is how we compute displacement. But don't forget, VT graph का जो area है, with the help of that, we can also calculate the distance. And now, how does it happen? Let's try to see. Just to understand all those things, एक VT graph बनाते. Randomly, I'm making a VT graph, and this is V, this is T, and let me say I have something sort of this graph. Doesn't matter what's the shape, but this is the VT graph. Now with the help of this VT graph, if I have to calculate the displacement, so how am I going to do? Suppose this area, that is A1, or मान लेते हैं this area is A2, alright, in terms of area. अभी हम positively लिखेंगे, that's the area. But इसमें से, if I have to calculate the displacement, that is A1 minus of A2. Displacement की बात हो रही है. So if it's a negative area, इसका मतलब the particle has returned. और खास तौर से आप देखिए, this is the situation. And अगर इसी में, if I have to write the distance, if I have to write the distance, that distance will be equals to A1 plus of A2. That is the situation. तो VT graph की मदद से you can calculate displacement as well as distance. Notice distance के केस में the A2 has been included with the positive sign. Now a little bit of question before. All right guys, now be ready. इसके नीचे जो time है, let me write it as T1, this as T2, this as T3, and this as T4. यहाँ थोड़ा सा messed up हुआ, I'm sorry, but you can manage it. 0, T1, T2, T3, T4. Now I want the question in this way. Is given graph में, I can see there is a turning point. Turning point के बारे में हमने पिछले क्लास काफी डिटेल में बात की थी. So you just need to tell me at what time is there the turning point. 0, T1, T2, T3, T4 या हो सकता है between T1 and T2, between T2 and T3, anything it can be. तो आपको बताना है where is the turning point. Come on, your time starts now. टिक टिक 1, टिक टिक 2, क्या कहें? ये हम हैं, ये हमारी क्लास है और हमारी पढ़ाई हो रही है. Alright, some answers are coming, but मैं अभी नहीं बताऊंगा. आपको टर्निंग पॉइंट के बारे में बताना है. व्हाट्सएप के थ्रू डाउट्स का यही फायदा है, एक का आंसर दूसरे को नहीं दिखाई देता. ओके, अर्नो सेज एट T1. लेट्स सी. ओह सॉरी, मुझे नहीं बताना था. नो प्रॉब्लम. आंसर्स आने लग गए. अभय हैज सेंट अ सर्टेन आंसर. निखिल हैज सेंट अ सर्टेन आंसर. राहुल, ओके. बाकी कहा गए जनता, गांव वालों आंसर भेजिए प्लीज. नीलेश दृष्टि, माय आंसर A1 प्लस A2. बेटा हमें टाइम चाहिए, हमें टाइम चाहिए. अनन्या सेज दैट इट्स T2. ओ आई सेड इट, नहीं बताना था. आर्यन देव, बस आप आर्यन देव लिख दीजिए, काफी है. फ्रॉम चित्रंजन. ओके, सो आई गॉट लॉट्स ऑफ आंसर. सबसे पहली बात, बाकी कोई है बिल्कुल चुप होके बैठे, नो प्रॉब्लम, ध्यान दीजिएगा. ओके, लॉट मेनी. राजन जी दिखाइए. और अशी, बिटवीन T2 एंड T3. ओके, भावना सेज T1. एक्चुअली देखिए, लेट्स अंडरस्टैंड व्हाट इज द मीनिंग ऑफ टर्निंग पॉइंट. जहां मुझे लग रहा था दिस इज द पॉइंट वेयर यू वुड गेट कंफ्यूज्ड, आई कुड फाइंड दैट. टर्निंग पॉइंट का मतलब है उस पॉइंट के बाद द डायरेक्शन वुड बी रिवर्स्ड. मेजॉरिटी ऑफ द स्टूडेंट्स ने ये लिखा है T1, क्योंकि आपने देखा वेलोसिटी की वैल्यू मैक्सिमम से कम हो रही है. बट दैट इज नॉट रिवर्सल. यहां देखिए, यहां भी पॉजिटिव है वैल्यू, यहां भी पॉजिटिव है, यानी पार्टिकल अभी भी आगे जा रहा है. वेलोसिटी की वैल्यू कम हो गई है, बट एज लॉन्ग एज, ध्यान से सुनिएगा, एज लॉन्ग एज वेलोसिटी इज पॉजिटिव, वो तो आगे ही बढ़ रहा है. द कैरेक्टरिस्टिक ऑफ टर्निंग पॉइंट, लास्ट क्लास किया था, इज वेयर द वेलोसिटी इज 0. द कैरेक्टरिस्टिक ऑफ टर्निंग पॉइंट इज द वेलोसिटी इज 0, और वेलोसिटी 0 यहां है. So congratulations to all those students who said T2. Nilesh Drishti, very good. T2, wonderful. So that is the time जहां पर velocity की जो value है that comes out to be 0. Please don't get confused with this. यहां कहीं पर भी आप देखें T1 के इर्द गिर्द, at the vicinity of T1, velocity is still positive. Velocity की value कम हुई है, but the direction has not reversed. जबकि T2 से पहले velocity was positive, T2 के बाद velocity is negative. That means the reversal has happened. मैंने क्लास के beginning में आपको ये बात बताई थी. We are going to talk about simple things, but इन्हीं simple चीजों में से we are going to extract. और यकीन मानिए, these are the sort of questions or these are the sort of thought processes that you require. Okay? All right. So एक और राजन जी दिखाइए. Okay, Tejas says that's T2. That's very good. देखिए, आप लोग मानो या ना मानो, मेरी क्लास स्मूथ कंडक्ट होने के लिए राजेंद्र जी हैं, बहुत मदद करते हैं. आपके एक एक मैसेज को वो छांट के दिखाते in front of my screen. Okay? Let's see now. Let's go with another numerical now. Here's the numerical. Velocity of the particle is 4 minus t. हमें निकालना है distance and displacement. We got to see. चलिए, let me help to a little bit of extent. So velocity is equals to 4 minus t. देखिए, एक तरीका है इसे आप numerically solve करें, but ये बात बिल्कुल सही है that integration of velocity will give you displacement, but जहां distance की बात है you got to be careful. और इस expression में there is a turning point. अब mentally calculate कीजिए where is the turning point at t equals to 4 second, क्योंकि उस टाइम में जाके the value of velocity has become 0. तो numerically बिल्कुल कर सकते हैं, but that's going to take a bit of longer time. Now we'll see इसी question को if I do it in a graphical manner. आइए देखते हैं एक बार. सबसे पहली बात, why did I approach for the graphical one? आप ध्यान से देखिए. This is y-axis, this is x-axis. So I can see the VT graph is a straight line. क्यों? Because it is in the format of y equals to minus of mx plus c. It's in that format. क्योंकि t का जो power है, that's 1. The power of velocity, that is 1. So it's a clear-cut indication that the graph is a straight line. एक बालक या बालिका किसका मैसेज बहुत आ रहा है? सेकंड मैसेज दिखाइए राजन जी. Describe application of radioactive isotope. I'm very sorry, this is the class of kinematics, so I would not be able to go there, right? But still I appreciate कि आपने मैसेज भेजा thinking of a solution, but sorry because it's going there. एक और है unread, दिखाइए जी. All right, okay, now let's see. तो ये है VT graph. पहली बात तो हमने डिसाइड कर लिया this is a straight line. तो एक काम करते हैं, the basic way, the graph जिसका slope negative है और y intercept positive है. Why is the slope negative? Because t का जो coefficient है that's -1. And the slope, Tejas has sent the answer, let's see. तो इसका जो graph है कुछ ऐसा बनेगा. This is the sort of graph that I'll get. क्यों? Slope negative. That means गिरता हुआ graph, falling graph. Y-intercept positive. Now let's try to fill up the value. T equals to 0 पे velocity is 4 और t equals to 8 पे, let's see how much is the value of velocity. T को 8 रखूं, 4 minus 8, that is -4. Cool. और ये पॉइंट एक बार निकालते. ये पॉइंट का कैरेक्टरिस्टिक है जहां वेलोसिटी 0 है. सो वेलोसिटी 0 आप देख सकते हैं t इक्वल्स टू 4 सेकेंड पे आएगा. बस इस v को आप 0 रख दें, यू वुड गेट इट. तो आपने क्या किया है, यू हैव प्लॉटेड द वेलोसिटी टाइम ग्राफ. जिनके हाथ ग्राफ में थोड़ा सा तंग है, where you are a bit less confident in plotting the graph, this idea is certainly going to help you. First, we decided that the graph is a straight line. उसके बाद ये वैल्यू कैलकुलेट करने के लिए t को 0 रखा. t equals to 8 minus 4 और 8 क्यों? Because यहां तक करना है. And at this point, the velocity is 0. Alright? अब देखते हैं, let's calculate the area. तो ये जो area है, that comes out to be 8, half base into height. Similarly, this area comes out to be 8. और हमें चाहिए था the value of distance. So distance is going to be 16 and displacement, positive, negative, equal. So the displacement will be 0. So distance is 16, displacement is 0. Tejas, a hearty congratulations to you, boy. आपका जो आंसर है बिल्कुल सही आया है. That's great. So I hope see, ये जो क्वेश्चन है, अगर आप नीट के रेस्पेक्ट में कहेंगे थोड़ा सा लेवल है, बट इस लेवल तक आपको आना होगा. दिस इज व्हाट द नीट एग्जामिनेशन requires. Okay? Tejas, can't we simply integrate for displacement? बिल्कुल कर सकते. If you noticed, शुरुआत मैंने यही बात कही थी. As long as displacement की बात है, you can straightway integrate. बट क्योंकि डिस्टेंस भी हमसे पूछा गया है और मैंने ये भी देखा 0 से लेकर 8 सेकंड के इंटरवल में बीच में एक टर्निंग पॉइंट भी आ रहा है, तो न्यूमेरिकली Oh, now Tejas is in class 9th and that's very, very wonderful. Great. Great. That is great. Take care. So this is how we start solving it, and you could see this is the pattern that you get. Chaliye, we have talked about position, velocity, forward gear, backward gear. Position की मदद से we have calculated velocity, velocity की मदद से we have calculated position. अब हम बात करते हैं about the second terminology, that is the acceleration. नाम ही काफी है. अगर acceleration है, इसका मतलब velocity changes. So what's the function or the job of acceleration? Well, this acceleration is what we call as the velocity changer. अगर acceleration है, then certainly the velocity will change. But अगर हम motion in a straight line की बात कर रहे हैं, we know for obvious reason the direction does not change. That means motion in a straight line के context में the acceleration only changes the speed, because we know the direction factor, that is constant. So I hope that part is simply clear. One thing that I would like to tell you, मान लेते acceleration की जो value है आपको 2 meter per second square दिया गया है. So let's try to dissect this unit. Let's try to see. इसको अगर हम ऐसे कहें 2 meter per second, this will give you the bigger meaning. वैसे कहने को हम 2 meter per second square कह देते, but आप यही कहिएगा, but mentally keep this thing in mind. 2 meter per second square मतलब 2 meter per second. इसका मतलब क्या है? It means the velocity changes. That's very important. The velocity changes by 2 meter per second every second. तो आप देखिए यही जो acceleration शब्द है, the unit of acceleration has lots and lots of meaning hidden in it. Alright? So next time when someone says acceleration is 2 meter per second square, तो आप कहेंगे इसका मतलब है velocity changes by 2 meter per second every second. Alright? So that is the part what you need to be careful. और अब हम देखेंगे जिस तरह से we had calculated instantaneous velocity, जिस तरह से we had calculated average velocity, now it's turn that we calculate the average acceleration and the instantaneous acceleration. Let's see. Okay. So to do that, here is the case. By the name itself, average का मतलब है which is defined in a interval of time, or instantaneous is defined at 1 instant of time. So average acceleration we define in this way. Average acceleration is delta v by delta t, because it's happening that the motion is in one dimension. So direction will be managed by plus and minus. तो बहुत specifically इसके ऊपर we don't give the vector sign. And इसका मतलब है v2 minus v1 divided by t2 minus of t1. That's the average acceleration. जो भी interval आपको दी गई हो between this second to this second, you're going to calculate that. While on the other hand, the instantaneous acceleration is defined at one single instant of time. एक पल के लिए. Like if you see the word acceleration at 3 seconds, acceleration at 4 seconds, precisely एक point पे define करते हैं, and that is equals to dv by dt, the derivative of velocity wrt time. There is also one other expression for instantaneous acceleration. ये तो आप तब use करें when velocity is a function of time. Say for instance, हमें ये दी गई है that velocity is a function of position. So in that given case हम इसको further ऐसे भी लिख सकते हैं. I'm using the chain rule dv by dx multiplied by dx by dt. ये और ये एक ही चीज है by using the chain rule. Okay. Okay, there is a question. Why not vector sign? Tejas, आप vector sign use करना चाहें, बिल्कुल आप use कर सकते हैं, but that is not required when the motion is happening in one dimension. Unnecessary है, because for motion in a straight line, the direction is given by plus and minus. Are you getting that point? तो आपको ऊपर vector लिखने की जरूरत नहीं है. Alright, so now the acceleration dv by dt और इसी को लिखेंगे dv by dx multiplied by dx by dt और further हम इसको ऐसे कर सकते हैं, ये जो dx by dt है that's velocity multiplied by dv by dx, that is acceleration. So guys, basically acceleration का दो expression है, या तो ये या तो ये. That's the instantaneous or average ये है. This is going to be a formula chart. This is going to be a formula chart. Okay? ये कब use करेंगे? When velocity is a function of position. और ये कब use करेंगे? When velocity is a function of time. Alright, now before we move further, there is a very valid question जहाँ पर अक्सर student misunderstand करते. Now if you know already, that's a very good sign. तो यहाँ से testing होगी. If I say that the, यहाँ ध्यान से सुनना, आपको ये दिया गया है that acceleration is minus 4 meter per second square. That has been given. Now my question is this a retarded motion? Is this a retarded motion? Is it a retarded motion, not a person? Okay, retarded motion. मैं आपको option दे देता हूँ. All right. Number A, yes. Number B, maybe. Now, what is that? Please don't answer the question on psychological basis. अच्छा, ये क्यों पूछते teacher? So not in that way. Think about it carefully. You should have a valid logic for that. So I need the answer कि acceleration की जो value है, that's minus 4 meter per second square. Is it a retarded motion? Yes or maybe. That is the situation. चलिए, give the answer. Some answers are popping out. Okay. ये नाम दिखाया राजन जी, ये जो अभी आपने स्क्रीन पे मुझे दिखाया है. I don't get the name. चलिए, वो नाम नहीं है, no problem. Okay, okay. Let me not read it. Okay, Tejas has sent, Arno has sent. Sushant from Lucknow. Answer पेश किया जाए. Okay, 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 okay. I got it. Thanks for sending your name. आपने पहले आंसर भेजा, उसके बाद अपना शुभ नाम भेजा. That's great. For those viewers, those who are not getting the way how to report the answer, WhatsApp के through भेजिए 9311883484. नंबर आप सेव ही कर लीजिए आकाश एडू टीवी के नाम से. This class is primarily being live broadcasted throughout the planet via Airtel television. All right, तो अब देखते हैं. Actually, is it a retarded motion? If your answer is yes, that would be wrong. It has to be maybe. अब जरा ध्यान से देखिए. Because the type of discussion that we are doing is a vectorial discussion. हो सकता है till your high school level, positive acceleration का मतलब speeding up, negative acceleration का मतलब speeding down. You must have certainly studied in that way. Even I studied in that way. But आज के बाद कसम खाना, you need to promise कि ये जो discussion हम कर रहे हैं, we are doing in a vectorial way. और Tejas has sent the correct answer that ये negative का मतलब it's a pure direction. Remember, the negative sign in case of acceleration is the direction. All right? You know, I call this sort of moment in physics as wow moment. Simple fact है, but there are lots of meaning. और जिन्होंने पहले numerical किया था, wherever you had the problem, wherever you made some mistakes, these wow moments are going to help you. So we are in constant search of wow moments, okay? That's how we can enjoy this subject. नहीं तो physics और physics पढ़ाने वाले दोनों ही बदनाम होते हैं अक्सर aspirants के बीच में. All right. So negative acceleration का मतलब direction है. It is not necessary that it is retarded. अच्छा, कैसे? मान लेते acceleration की दिशा ये है और velocity की दिशा ये है. Now, the acceleration is negative, but the velocity is also negative. So since both are negative, इसका मतलब it is speeding up. Actually, particle की जो speed है, that is increasing. Alright? But मान लीजिए acceleration ये direction में है, यानी acceleration positive है, but velocity is in this direction. अभी आप देखेंगे, this indicates that it is speeding down. This is speeding down. जी हाँ. बावजूद इसके, the acceleration is positive. Still, it is speeding down. Still, it is speeding down. Simple for the reason, the direction of acceleration and velocity, they are opposite. So, आगे से, when you want to find out whether the speed is increasing or decreasing, never you're going to see the sign of acceleration. आप क्या देखेंगे? The relative direction of velocity and acceleration. If the velocity and acceleration are in the same direction, मायने नहीं रखता है, negative क्यों ना हो, but that will be speeding up. If the velocity and acceleration are in opposite direction, that will be speeding down. I hope that's clear. चलिए, let's go for a numerical. Here it's there. X की value दी गई है. You got to calculate the average acceleration from 1 second to 3 seconds. Instantaneous acceleration at t equals to 1 second. That's straightforward, going to give you a practice. Okay, so let me also parallelly start ताकि हम time बचा सके. We can go with something like this. So चलिए लिखते हैं solution. सबसे पहली बात, I would just like to tell you, we will find out the reason कि हर एक step के पीछे का क्या कारण है. Let's try to find that. Like the definition of average acceleration is delta v by delta t, यानी change in velocity divided by the time interval during which the change occurred. तो हमें ज़रूरत होगी velocity की. इस तरह से हम बिल्कुल targeted होके चल रहे हैं कि हमें इस चीज़ की ज़रूरत है, so we'll calculate that. Alright? तो velocity, that is dx by dt, and that comes out to be 3 की derivative 0, this one, the derivative of 4t, that's 4, t cube की जो derivative है, that's 3t square, 3 कट जाएगा, minus t square. So that is the velocity, 4 minus t square. Okay, so first we got the expression of velocity. अब हम निकालेंगे average acceleration, that is v3 minus v1 divided by 3 minus 1. So let's see. 339, so that's minus 5, velocity at 3. 1 पे, that's going to be 3, और time interval, that's 2. तो ये बन जाएगा minus 4 meter per second square. That is the average acceleration in that given time interval. The time interval of 1 to 3. That's the first condition, all right? Okay, now let's go for the next one. अगर हम instantaneous acceleration की बात करें, now I would like to go for the instantaneous acceleration. और last class भी हमने बताया था, it's not कि आप पहले value put करोगे फिर differentiate करोगे, right? You have to differentiate first and put the value. Remember the last thing that we had talked about. तो velocity का जो derivative, here is the velocity, 0 minus of 2t, so that is minus of 2t, right? और हमें चाहिए at t equals to 1 second, तो acceleration at 1 second, that is minus 2 meter per second square, and we are done. तो ये है instantaneous acceleration और ये है average acceleration. I hope that has really made sense. So now you can proceed in this manner. Okay, okay. There are some messages जो unread हैं, दिखाएं please. राजन साहब मैसेज दिखाइए. नीलेश दृष्टि -4 and -2 आएगा, एक माइनस छूट गया लेकिन वो गलती से छूट गया होगा, मुझे पता है. वंडरफुल नीलेश दृष्टि. एक और मैसेज है, क्रैश कोर्स कब से स्टार्ट है, मुझे ज्वाइन करना है प्लीज. बिल्कुल आपको बता देंगे. आप एक बार ऊपर का जो दिया गया ईमेल आईडी उस पे जरा लिख लीजिए. आपको हमारे जो रिप्रेजेंटेटिव्स बहुत अच्छी तरह से शेड्यूल बता देंगे. But there is a crash course which is going to start. And thank you very much for your interest. That's great. Okay, so now test series and crash course, they will give it. एक short email आप लिख देना. That's more than enough. Okay, so this is the average acceleration, instantaneous acceleration. एक और numerical करते हैं, and here is that. लो जी, आपके सामने है. Velocity is ये थोड़ा सा अलग होगा. एक बार यहाँ आते हैं graphically. वो थोड़ा सा अलग context में. Let's come to this point. Graphical representation. हमें calculate करना है acceleration. All right. We want to calculate acceleration from the velocity graph. कोई भी graph करने से पहले एक rule of thumb जो हमने बताया था, अगर forward gear है somewhat slope is required. अगर backward gear है integration area is required. आपको ये एक generic idea दे देता है, उसके बाद fine tuning कर लेना. All right? But the graph that I have is here, VT graph. Okay. अब हम कैसे आगे बढ़ेंगे? जिन जिन को graph में problem है, I hope this is really going to help you. Acceleration की जो value है, that is dv by dt. That's the definition. Then I know कि ये तो slope of tangent बताता है. The derivative says the slope of the tangent. But slope of tangent of which graph? Of the VT graph. So this gives that acceleration is the slope of tangent, right? Slope of tangent of VT graph. ये है. जिसको आप normally tangent कहते हैं, actually tangent is a line, but tan of theta लिखते हैं, that's the slope. तो complete sentence है slope of tangent. So let's see how it goes. मान लेते you are interested to calculate the acceleration graphically, और ये कोई point है, suppose. At this given point, you want to calculate the acceleration. Let us say that point is t1. आपको जानना है what is the value of acceleration at t1. तो इसमें ये करेंगे. You know what we are going to do? Tangent बनाएंगे. So I'll make a tangent here. Okay. अब थोड़ा सा इसको rearrange करते हैं. Lots of let me make it by hand itself. Okay, यहाँ से, boom, I think that's better. So this is the tangent कहाँ पर? At this particular point. और ये line tangent है, if I call this angle as theta, तो slope of tangent यानी इस example पे the acceleration यानी acceleration at t equals to t1 is equals to tan theta. है ना मजेदार बात कि आपके पास एक ग्राफ है and with the help of that graph, a little bit of computation, you could see you get the value of acceleration. आपको बहुत स्पष्ट तरीके से the values would be provided, like someone may say theta is 30 degree, theta is 60 degree, whatever, 45, whatever it's given, you can go with that. Now there's another graph which is the Vx graph. Now let's try to see with the help of Vx graph, how do we calculate the acceleration? Do remember this was Vt graph and this is Vx graph. तो क्या करेंगे? We're going to first of all write the definition, that is v dv by dx. अब जरा ध्यान से देखिए, v dv by dx में ये जो term है dv by dx, this dv by dx is the slope of कौन सा ग्राफ? Vx graph. जैसे कि dv by dt, that was the slope of Vt graph. dv by dx, that will be more precisely slope of tangent hai. So please understand, slope of Vx graph. So it's something like this. Say, मान लेते at a given point, suppose, okay, suppose I want to calculate यहाँ पर. अब ये point that's very very important. मान लेते I want to find the acceleration at x equals to x naught. आप देखिए x equals to x naught पे velocity की जो value है that is v naught. और साथ ही साथ let's draw tangent and let's call this as theta, यानी slope of tangent is going to be tan theta. अब जरा ध्यान से देखिए, the value of acceleration at x equals to x naught, that is equals to v naught multiplied by tan theta. Why v naught multiplied by tan theta? Because you see the expression slope of tangent multiplied by the velocity at that instant. That is very much important. Don't forget, it's a Vx graph. और यही अगर Vt graph था, which was the case, so it was simply the slope of tangent. But if it's a Vx graph, so that's going to be the velocity at that point multiplied by tan theta. So this is one area where students normally get confused. अब मुझे पता है, going forward, you're not going to get confused in this. All right? Okay. So this is the ending of today's episode. So it was all about calculation of kinematics. Next time again, I would like to see you in my class where we will interact, where we will learn wonderful physics. Thanks for joining me. I'll catch you up in the next one. Take care. Bye for now.